Hello and welcome, dear friends. In this video I'm gonna talk about coroutines. This is a very important topic for all those who want to succeed in game development. In particular, we will talk about classes that inherit from the yield instruction class. You can also find my tutorials on Udemy. You will learn how to create strategy games in Unity. Links and discount coupons are in the description of this video. Without further ado, let's get started. Okay, we have two heroes. Archer shoots at the troll, nothing complicated. Unity displays damage in one frame instantly. That is what I want to change. I want Unity to display damage within a second or two. We will modify the troll's behavior in the second part of this video using coroutine. Now I'm gonna start by sending some messages to the console window. The background object has the background script on it. Let me open it. Normally, if you call a method, C# will run all statements line by line. This effectively means that any action taking place in a function must happen within a single frame update. And when you call a function, it runs to completion before returning. There is no way to pause the method's execution, there is no way to do anything else. This is not very convenient, since there are many tasks in game development that require pauses or delays. For example, I would like these messages to be delayed, appear every 2 seconds. Well, I can do it inside the update method. Just counting the seconds, I can send a new message every 2 seconds. To be completely honest, every custom behavior you can imagine can be implemented using start and update. However, events that happen over multiple frames are harder to code. This often leads to code that is not just harder to write, but also harder to maintain. It would be great to find an easy way to handle situations like this. To create a coroutine, you need to take 2 steps. First, you need to create a method that will act like a coroutine. Second, we need to run it. A coroutine returns IEnumerator interface, so the return type will be IEnumerator. This iterator is also a very interesting entity in C#, but it is worthy of an individual video. Unity treats coroutines as lists of codes. We can say that IEnumerator helps to iterate this list to stop the process at a specific moment and gets back to that point whenever you need it. To complete a coroutine, we need to return something. Yields is a keyword. Objects that return IEnumerator can be treated as collections and can be iterated using for each loop. In this context, yield is the way to return an object selected by the loop. All types the coroutine returns can only be used with a yield statement. One of the classes a coroutine can return is waitForSeconds class. This class inherits from yield instruction class, and its constructor requires one parameter of float type. This syntax implies that Unity executes everything that is written after yield after a pause of 2 seconds. In this case, the method prints the second message, waits another 2 seconds, and sends the third message to the console. It remains to call the coroutine. To start the coroutine, I will call the startCoroutine method. The method has only one parameter of IEnumerator type, and it's gonna be the coroutine. Okay, let me hit play. We see all 3 messages. The second and third messages appear after a pause of 2 seconds. Cool. Actually, if a coroutine is called inside the start method, we can use another syntax. Like this, without calling the start coroutine method. we will get the same result. Let's see. Okay, so far so good. The wait for seconds type is not the only type the coroutine can return. Here is the list of classes I'm gonna talk about. Let's examine them one by one. I believe it is important. First, I will enable the update, fixed update, and let update methods. All update methods are called once per frame. The code block of the if statement, however, will be called only once. According to the execution order, the fixed update will be called, then update, and the last one will be the late update. Let's see. Yes, that's right. Okay, let me enable the next coroutine. Normally the start method is called before the update, but wait for fixed update waits for the fixed update method to be executed. We will see the message right after fixed update, but before updates. Let's see. Take a look at the console window. Wait for fixed update is executed right after fixed update. Let's go ahead. The wait for end of frame is used more often. Sometimes before executing the methods we have created, we have to wait until Unity executes all built-in methods. Wait for end of frame waits until the end of the frame after Unity has rendered every camera and GUI, just before displaying the frame on screen. Now let me run the play mode. The coroutine is executed after all update methods. Let's go ahead. The yield return null is almost the same as wait for end of frame. One returns just before rendering, the other returns just after, but just before the frame is displayed. When the difference isn't important, I usually use and recommend yield return null. I don't think there is a big performance difference. If I hit play, I will get the same result. Wait until and wait while are a bit more complicated, but just a bit. I don't use them often in practice, because I prefer to use the while loop instead. But let me give examples of how the wait until and wait while can be used. The wait until suspends the coroutine execution until the condition in parentheses evaluates to true. The only difficulty here is that the parameter is a delegate. We're gonna make it simpler just to make it clear. The start method runs two coroutines. The first one sets new value to the string variable after 4 seconds. It is a class scope variable. The getPatience condition method returns true when the value of the string variable becomes equal to isDead. Simplify it as much as possible. And the second coroutine prints the first message, then waits until the getPatience condition method returns a true value, and after that prints another message. Since the parameter of the wait until constructor is a delegate, I haven't added the parentheses when calling the methods. Let me hit play, wait for 4 seconds, and we see the second message. We can use another syntax using the lambda expression, like this. In this case, we don't need to create the getPatience condition method. The result will be the same. Wait while has the same syntax and logic. The only difference is that condition in parentheses must return a false value. To make it work, I will replace the string value. While the condition is true, the coroutine will be suspended. Let's see. Good. I hope it's clear. The while loop is logically very close to wait until and wait while. Let's have a look at another example. While the condition in parentheses returns true, the code block of the loop will be executed. In our case, Unity once per second will send the message to the console window, 4 messages in total. When the condition returns false, the coroutine is terminated. When using the while loop, make sure that it doesn't make the coroutine endless. At a certain point, the condition must return false to stop the coroutine. We can stop coroutines at any time. Stopping coroutines basically means an early exit. It is not required constantly, since we often use yield return null or other classes to stop the coroutine, but in some cases you need to know how to stop the coroutine. Okay, let's see it in action. The coroutine here is supposed to print 2 messages. We will see the first message right after we press the play button. The coroutine will be stopped after 2 seconds, so I guess we shouldn't see the last message. The update method calls the stop coroutine method. We have to add the coroutine name as a parameter. Let me hit play. We see the first message, but we didn't receive the second message. We can also pass the coroutine itself into the method as a parameter. In our case, it is the start method. We will get the same result. We can also stop all coroutines that are members of the same class. Let me add one more coroutine with the same logic. To stop all coroutines, I will call the stop all coroutines method. There is no need to specify names, all coroutines will be stopped. Let's see what messages we will get. Okay, both coroutines were stopped after 2 seconds. If a game object is destroyed, all running coroutines that belong to the destroyed game object will be also terminated. I believe this part is clear. We can also make the parent coroutine work in parallel with the child one. When invoked like this, the child coroutine coexists in parallel with the original one. They do not interact directly, and most importantly, they do not wait for each other. Note that we see "if you are a billionaire" message before the message of the second coroutine. It is also possible to execute a nested coroutine and to wait for its execution to be completed. The simplest way to do this is by using yield return. In this case, the execution order will look like this, since the execution of the first coroutine is suspended during the execution of the second coroutine. Let's see. Let me hit play. The second message of the first coroutine is sent after the second coroutine is executed. This particular case, however, doesn't need to start another coroutine. We can optimize this by writing something like this. Executing the second coroutine as a traditional method has almost the same effect. The only difference, however, is that the methods will be executed in a single frame. The reason why the first example was shown is to introduce more complex behavior, for example this one. And here is the execution order. The coroutine prints the first message, then runs the first child coroutine, and at the same time it continues the execution. We also say that the first child coroutine is executed asynchronously. The assignment here helps to yield the child coroutine. When this happens, Unity suspends the parent coroutine and waits for coroutine B to terminate. And only after that it continues execution. Let's check it out. Everything is as expected. The code becomes much more flexible, especially since we can add multiple child coroutines. Of course, instead of sending messages in practice, you can do whatever you need. I think I have been talking for a very long time. Let's do something more interesting. something closer to a real situation. Open Unity. The archer is shooting arrow at the troll. The arrow always reaches the target, dealing some damage, but Unity displays health reduction instantly, within one frame. I want to change this. Let's make it all look a bit more interesting. Okay, the troll object has the troll script on it. Let me open it. Let's see what we have here. Let's start with fields and properties. The first two fields are visualizing the damage. I believe there is nothing to explain. The max health is the initial health. For example, you can use the stack instead. The number of iterations shows how many times the reduction in health will be displayed. I will set its value in the inspector window. Health reduction per iteration property will be calculated. The restrictions set by a property eliminate mathematical rounding errors. You will see the formula in a bit. The current health is the health Unity will display every iteration. Property restriction doesn't allow current health to take negative values. The start method displays the initial health and sets max health to the current health variable. The countdown to target health coroutine is called when an arrow hits the troll. Let me call it first. I will not focus on all references and methods. These methods are standard. The target health calculates health after the troll takes damage. The next line calculates the health reduction per iteration. To avoid float numbers, Unity rounds the results to the smaller integer. Rounding, however, generates miscalculations. We will handle it a bit later. The wait variable is a pause in seconds. It is a very short pause. The while loop compares the current health with the sum of target value and damage done per iteration. This way we eliminate negative values. The display current health method displays the current health. The current health should be reduced by the damage per iteration. The last line of the while loop suspends the coroutine execution for amount of seconds defined by the wait variable. Since the rounding may generate a miscalculation in some cases, the last step is to make the current health equal to the target health. Nothing complicated. Okay, let's see it in Unity. Open Unity. I will set, let's say, 25 to the number of iterations variable. The max health is equal to 1000, it is okay, and make sure that the child text mesh pro object is assigned to the health text fields. The animator component also. Okay, hit play. Now it looks a bit better. Cool. I hope you enjoyed this video. Thanks for watching.